So good morning, everybody. Welcome to class.
Good morning.
Morning. So
Morning.
we're gonna practice how to add, how to subtract fractions. Okay. So last time, I think when we met last time, we saw how to find the least common denominator, right? Or the LCM. You know, so that was just the first piece, how to find the LCM. So now we're gonna go ahead and try to see how to add, how to subtract fractions, all right? So let's say we're gonna start with this type of examples. You know, we have this, for instance, all right? So I have 3 over x. Okay, you don't see, obviously you don't see what I'm writing because I'm not sharing my screen yet. So, all right, okay, now it does work. So when you have this 3 over x plus 4 over x squared, right? Do we have the same denominator? The answer obviously is no, we don't have the same denominator, right? Okay, since we don't have the same denominator, we have to find what we called last time the least common denominator, right? Okay, so now here our two denominators are x and x squared, the same variable, right? Same x and x squared. Last time, can somebody tell me what we said if we have the same variable, right? The LCD would be the expression with the highest exponent or the lowest exponent?
The highest.
The highest, thank you. The LCD would be the one with the highest exponent, right? Which is here, x what?
X squared.
Right? That is LCD. By the way, any common denominator would work, right? But why we say is the least common denominator, because it's going to lead to a more simplified answer, okay? But any common denominator would work. So here's the LCD here is x squared, right? The highest exponent. Okay? Okay, so since it is x squared, now I have to change any denominator that is not x squared. I need them to become x squared, right? Okay, so the first fraction, do I have x squared at the bottom yet? I don't, right? What do I need to do? How much I need to multiply the denominator by to get x squared? Can somebody tell me?
By x.
By another x, thank you. You see, x times x is x squared. So since I did it at the bottom, I have to do it at the top, right? Okay. The second one right there, do I need to change it? Or is it okay now for that one? The second denominator.
It's okay.
It is okay, right? Because I already have the x, no, I already have the LCD. So what I get 3x over x squared plus 4 over x squared, which happens to be 3x. Now that we have the same denominator, we just go ahead and add up the numerators, right? And that is it. Okay. So that is it. So I'm done adding these two. All right. So if I go ahead and ask you to do this one right here. Okay, so we're gonna go gradually, of course, right? we're gonna go gradually. The first examples are not really, very hard, right? Okay. So I let you, about 30 seconds for everybody. Find the LCD, and then do what is necessary to get the same. Find the LCD, right? And do what is necessary. You see, multiply this one, multiply here, multiply here, and get this minus this, and then get this, right? All right, so, okay, somebody, what do you think is how much is the LCD, you think?
24R.
24R, right? You see, thank you very much. That is the least common denominator, right? 24R. The R obviously is the same, right? And the LCD between 6 and 8. Remember, the other name for the LCD is LCM, the least common multiple, right? What is the very first number? That is a multiple of 6, and a multiple of 8 is 24, right? So that is 24R. So now you need to multiply the first denominator by how much to get 24R?
4.
By 4, right? So if you do it at the bottom, we have to do it at the top, right? And we need to multiply the second one by how much to get 24R?
3.
Second one by 3, right? 3 here, 3 here. So what do we get? We get 20 over 24R minus 15 over 24R, right?
Mhm.
Which combine to 5 over 24R. Okay? And that is the final answer right there. So, okay. Gradually. So try to do this one, everybody. Again, same thing. Find the LCD, okay? And then go from there. All right, so how much is the LCD, you think?
Is it 18t to the third power?
Thank you. That is absolutely correct. You see, 9 and 6, 18 is the very first number. That is a multiple of both, right? And then we said for the t, for the variable, we take the one with the highest exponent, right? 18t to the third. All right. So now the first one, it needs to be multiplied by how much? At the top, at the bottom?
2.
Only 2. Thank you. And the second one needs to be multiplied by how much?
3.
3.
3 what? 3?
3t.
3t, right? 3t. Everybody agree with that? It's going to be 18 over, 16 over 18t cubed minus or plus 15t over 18,
18t.
right?
Mhm.
And then which is end up to be 16 plus 15t all over 18t cubed. Everybody got that?
Yeah.
Yeah. Yes, that's good. You see, and then so we're going to keep going right here. So we're going to keep, you see, the next examples. So probably it's going to be a little bit different. Okay, let's say now we have this one right here. This one is kind of a little bit different, all right? So it's still the same thing. What do you think? Remember last time, Tuesday, we saw if you have something like that, what would be the LCD, right? We saw that last time. Okay, what do you think? How much is the LCD here? We're going to do this one together. How much do you think is the LCD here?
X
minus 1x plus 1.
Thank you. Remember last time we said if two denominators are completely independent, which means they don't share no common factors at all, right? Which is the case here, then the LCD is just the product of both, right? It's like if you have the denominator 3 and you have the denominator 5, right? The LCD would be 15, which is 3 times 5, okay? So this is the same thing here. Since these two denominators, they have nothing in common, they don't have no common factors, the LCD is just x minus 1 parentheses x plus 1. You see, it is the first expression that includes both, okay? Is the smallest expression that include both right here. All right, since this is my LCD, I need to multiply the first denominator by how much to get. We need to multiply it by how much to get the LCD.
X plus 1.
All right, you see, every time what you're going to put the missing piece, right? I have the piece x minus 1, the piece x plus 1 is missing, right? So I put the piece x plus 1 here. And since I did at the bottom, I have to do it at the top. Okay? And the second one right here, what piece is missing for the second denominator?
X minus 1.
X minus 1 is missing, so I put x minus 1 and here x minus 1, right? So now what I got? I got this right here, a single fraction where I got x plus 1, x minus 1, which is LCD, right? See, that is a LCD. At the top, I have 2 times x plus 1. And I have plus 2 times x minus 1. Okay? If I write this, I am on the right path to get the right answer. All what you have to do next is to simplify, right? That's it. All what you have to do next is to simplify, which is 2x plus 2. This is 2x minus 2. And these two cancel out. So we get 4x over x plus 1, x minus 1. All right. So that is how we treat an example like that. So in the same token, if I ask you to do this one right here, all right, go ahead. Try to do this one. You have to find what is the LCD and then go from there. All right, so can somebody walk us over the steps, please?
Is the LCD x plus 6?
Okay, that is a good question. You see, when you say x plus 6, because I understand you isolated 2 and you isolated 3, and say, okay, since the LCD of 2 and 3 is 6, that's going to be x plus 6. You see, the x plus 6 would come from there, but we cannot isolate the 2 and the 3. We cannot. X minus 2 is a block, is one thing. Okay, x plus 3 is one thing. You cannot just take away the 3. You cannot just take away the 2. Okay, so I treat x minus 2 as one single thing, I treat x plus 3 as one single thing, okay?
Mhm.
So that is why the LCD is not that. So what is the LCD you think? Somebody else?
X minus 2, X plus 3.
Exactly. We said if the two denominators, they don't share no common factors, right? Like here, this is the case. They don't share a common factor. X minus 2 as a factor is completely independent as, to x plus 3, completely independent. So the LCD will be just a combination of both. This is x minus 2, x plus 3. Everybody, if you see something like that, you want to remember this rule, everybody? If the two denominators are completely independent, the LCD will be just combination of both, right? All right. Okay, now, after that is the LCD. What you do now? For the first one, what you do? What is the missing piece here?
X plus 3.
X plus 3 is a missing piece, right?
Mhm.
I mean, you see, please,
I'm sorry, X minus, yeah, X plus 3, I'm sorry.
yeah, X plus 3 is, I hope everybody, is trying to say, okay, so you don't have to talk, right? But, I hope everybody here is trying that because on the test, you're going to be the same stuff, right?
So are you,
Yes, go ahead.
are you taking the highest number and making that the LCD?
No,
So
that is
instead
not
of
the high, that is not the highest number because my denominators are not only numbers. My denominators are expressions, is x minus 2 and x plus 3, right? You look, for instance, if this was 1/3 plus 1/7, right? What we would say here is LCD. What you would say?
21,
How you got 21?
because it's the lowest factor that you can, 3 times
Yeah.
7 and
Exactly. That is my point. And in that case, the LCD is 21 because 3 and 7 have no common factors, right? When the denominators have no common factors, the LCD is just a combination, it's just a product of them, right? The LCD here is 3 times 7, which is 21. It is the same logic here. This one and this one, they don't share no common factors, right? Okay, when you see x minus 2, we don't isolate the 2. We don't isolate the 3. It is x minus 2 as a block. X minus 2 as an expression has nothing in common with x plus 3 as an expression. Every time that happens, the LCD is just a combination of both, right? It's just a multiplication. All right, it is the same logic over there. So now after that, we said, since this is x minus 2, the missing piece here is what? Okay, can somebody dictate me what they did? I don't want to do it myself, you see? Go ahead, dictate me what you did.
I multiplied the denominator and the numerator by X plus 3.
In the first one, right?
Mhm.
I agree with you, exactly. So now what you did to the next one?
I multiplied by X minus 2.
Because it is a missing piece, right?
Mhm.
Okay, the missing piece from the LCD, I put it here, right?
Yes.
See, now what you get now? As a single fraction here, what you have what is the common denominator which you want to put here now?
X minus 2, X plus 3.
Thank you. And then what are the new numerators now?
13 times X plus 3
Yes.
minus
Yes.
9
Yes.
times X minus 2.
Thank you. Yes, sir. That is, so now what you did next now?
I multiplied 13 by X and 13 by 3.
Exactly, 13x plus 39 minus what?
I multiplied -9 by X and -9 by 2.
That is correct. Negative 9x plus how much?
18. Yeah.
Plus 18. over x minus 2x plus 3, right?
Yes. Mhm.
And now which is, you see, the goal is to reach here because what comes next is how to simplify, right? But for you, your focus would be how to get to this piece right here. After that, it's just a matter of simplification, right? Okay, so which is 13 minus is 4x.
Mhm.
39 plus 18 is plus 57 over x minus 2x plus 3. All right, so
Wait, isn't it?
go ahead.
Oh, never mind. I thought it was minus 18. I see where I messed up.
Yeah, it's a plus
Never
18.
mind.
Yeah. All right. So now, okay, now if you have some like that now, I hope the internet will not let me down because it keeps saying my connection is weak, you know. And I am in my office at CCBC. All right, this one right here. Same thing, you know, I'm gonna let you find the LCD, okay?
That was the end. So that was the end of that last one. 4x plus 57.
Yeah, over x minus 2x plus 3, that is the end of it, yeah.
Oh, looked like I could do more.
Yeah, I mean, so here, unfortunately, look at the numerator. There is nothing to factor out of the numerator, right? So we just stop right here. Okay. So right here, this one here, what is the LCD? Again, what if you want to find the LCD, you cannot isolate the x minus 5. You cannot view it as x and 5. X minus 5 is x minus 5, right? As a whole, okay? Okay, think about that. Everybody, you know, I really want everybody to try to do, you know, I just don't want like a couple of people, you know, who tries the whole class, you know, All right, so, okay. I want somebody to tell me what LCD they got.
Well, isn't it, it's x minus 5
Uh-huh.
and 4x times 4x?
It's 4x times x minus 5, right?
Yes.
But you got, that is, okay, that is correct, because here, when I look at the two denominators, x minus 5 is completely independent from 4x, right? Again, we cannot isolate the x, you know, you cannot say x minus 5 is x and negative 5. It is x minus 5. So the LCD here is x minus 5 times 4x, and usually we write it this way, okay?
Yeah.
If you have a problem, you know, with that, so you have to, everybody, and here I'm talking to everybody, you have to say why the LCD is this, so we can explain it a little bit, okay? That is very important to find the LCD, okay? Because after we get the LCD, visually, I think what you have to do next is not like very complicated. You see? Okay, tell me, Noel, what did you do next?
So then you're missing a 4x out of the first denominator. So then you multiply 2 times 4x.
Thank you very much. You see, this one, the 4x, the x minus 5 is here, but the 4x is missing. So I put 4x, I put 4x. Thank you. And then the second one, what you did?
And then the next one's missing the x minus 5. So then you bring that up to the numerator, 3 times x minus 5.
Thank you very much. You see, that is absolutely right. So then we get a single fraction where we have 4x, x minus 5 here, which is a denominator, right? And then we have here 8x plus 3 times x minus 5. Now what you have left to do is just to distribute and do some simplifying, right? This is 8x plus 3x minus 15 over 4x parentheses x minus 5, which is 11x minus 15 over 4x x minus 5. And that will be my final answer. I will not try to do anything more, right? All right, thank you very much. So, and now here, our next one here is, you see, all the examples we did, we didn't have to factor nothing, right? But for this one, before we find the LCD, we will have to factor. All right. Yeah, me too. I have some connection issues, I think. Okay, right here. You see right here. Are we ready? Are we ready to find the LCD yet?
No,
ready?
because you can break down that x squared minus 25 as a square.
Thank you. Thank you. That was my question right here. So first, what you have to do, first is factor the denominators, right? And second, find the LCD. Okay? In all the examples we did previously, there was nothing to factor, right? But here we have to factor before we say who is LCD or not. Now, everybody does remember how we factor x squared minus 25?
X plus 25, x minus, x plus 5, x minus 5.
Thank you. X plus 5, x minus 5, that is correct, right? So this is x plus 5, x minus 5. Look now, everybody. So we factored, so this is a check. Now find the LCD. What do you think is LCD?
Well, it's still gonna be x plus 5, x minus 5.
Exactly. Why? Every time when that happens, every time you have one denominator that is a piece of the other one, then the LCD will be the big one, right? Okay. Every time that happens, it's like, you know, it's like the same example, same context. If somebody asks you, what is the LCD of 1/4 plus 1/8? What you gonna tell me? What is LCD of 4 and 8?
4.
Is I mean is
Eight.
what? Is 8,
8.
right? Why is it 8? Because 4 is already included in 8, right?
Oh,
Because 4 is a factor of 8, okay? So the LCD is 8 because 8 happens to be 4 times 2. So we already have 4 in here, right? So that's why the LCD is 8. Same thing here. Since this one is a piece of this one, so the LCD is x plus 5 times x minus 5. Okay? Because the LCD is x plus 5 times x minus 5, do we need to change the first denominator? Do we need to change it anyway? The first denominator, do we need to change it, or do we have already the LCD there?
No, we don't.
No.
have-
We don't have to change it, right? Because we already have the LCD there. What you have to do to the second denominator then? Fraction. You have to multiply here by
x minus 5.
x minus 5. Thank you. X minus 5. You see, this one we don't change it because this one has already the LCD. The other one we do change it. So it's going to be x plus 5, x minus 5. And here 4x plus x times x minus 5. Okay? You see, that is the goal we have to reach here. After we get this now what you're going to do next has nothing to do with the fraction stuff. It's just how to simplify it, right? Okay? But, you know, about the fractions, this is what we're learning today. How to get to that, how to get to this. This is what we're learning today. It's going to be, now we're going to just do x squared minus 5x. This is x squared minus 5x. So it's going to be 4x plus x squared minus 5x all over x plus 5, x minus 5, right? Which is x squared minus x over x plus 5, x minus 5. And then we can stop right here. Everybody got that?
So I get a little stuck on when to stop. So
Okay,
I'm
so if you
I'm
reach
tempted
up
to
to
take
here,
that. Yeah.
of course, you know, we can be tempted to factor out x, right? That is no harm, you can do that, okay? But why I didn't do it? Because I knew even if I factor out the x, there will be nothing to simplify after. You see?
Fair enough.
So that,
Yeah.
that is why I stopped right here. But if you do factor the x, it's okay. It's good.
Okay.
Yeah.
Okay.
All right, so let's give you another one which is, you know, which is kind of similar to that. All right, so we have these two, you know, take the first one, do exactly what we did before. All right, so can you tell me, somebody walk us over what they did for the first one?
Can I do it?
Mhm. Yeah, go ahead.
All right, so first we'd need to factor the first denominator using difference of two squares, which would be x plus 2, x minus 2.
That is right.
And then
Okay.
in order to get the least common denominator, you would have to put in x minus 2 on the end of the x plus 2, whereas the first one is already the least common denominator.
Yes, that is x plus 2, x minus is LCD. Same case, right? This denominator is completely included in the first one, so the big one will be the LCD, right? And exactly what you tell me, Katie. So you have to multiply this one by x minus 2 to get the same LCD. And do you do anything to the first fraction?
No, you leave the first fraction as is.
Exactly. The first fraction has already the LCD, so we don't do nothing to it. So then you have what? What is the common term you're going to put here?
X plus 2, x minus 2.
Yep. And then your numerator will be what?
First, you just have the 8 from the first one, and then distributing the 3, you would have 3x minus 6. So that would end up being 3x plus 2.
You see here the minus here. I would pay attention. You're almost right, but I would pay attention to the minus sign here, which is, because this, when you distribute here, you get 3x minus 6. I agree with you, right? Okay, but
it would be
look
negative
at the
3x.
negative sign here. The negative sign will affect everybody. It's going to be minus 3x plus 6, right?
Yes.
So which becomes 14 minus 3x over x plus 2, x minus 2. Thank you very much, Katie. All right. Okay, somebody else. Can you tell us here what you did with the second one? Somebody? All right.
I think
Go ahead.
we still need to. Oh, who?
Go ahead. Go ahead. What you say?
Noel, me? Go ahead.
Yeah. Go ahead, Noel.
Okay. Well, you need to break down that square first.
You broke it down as what? How you broke it down?
Wait a minute. Now you're making me doubt myself. I think Annette should answer this one.
I mean, go ahead. So
I know what he's trying to, I know what you're doing though, because that's tempting, but it's, if you break it down, it's x plus 3, x plus 3. Right? Isn't that what you mean, Noel?
Right. Never mind. Okay, I'm getting
That's what you mean.
x plus 3, right? I agree with that. X plus 3 squared is x plus 3, right? As long as we stop there. You see, what you don't want you to do is
Yes,
to go
do
ahead
it.
and
What?
distribute.
Just tell me.
Go ahead.
So yes, okay, so we're doing that,
Mm-hmm.
but we don't really need to. But now I see, oh, okay, we need it 2 times. So now I'm gonna multiply the 2 times x plus 3,
Uh-huh.
because that's x plus 3 is the common denominator. So then you've got, you factor out, you distribute the 2 to the x plus 3, so that's 2x plus 6,
Uh-huh.
10. And then you go further, it's 2x plus 16.
Okay.
Okay, so
X plus 10
x
over
plus
x plus
3,
3
x
squared.
plus 3, but
Mhm.
factor,
Yeah,
and then you factor.
you can stop
Huh?
there. You know, you can stop there. When you do 2x plus 10 over x plus 3 whole square, you can stop there. So you don't have to go any further than that. Okay. But just, you know, just to, for everybody to understand, here, look, if you look at the first denominator is x plus 3, the second one is x plus 3 squared. They are the same, it is the same expression, which is raised to second power in the second denominator, raised to the first power in the first denominator, right? I remember our very, very, very first example in this class. When that happens, we take with the one with the highest exponent, right? Okay. So I can tell here, without doing any breaking down, I can tell the LCD would be x plus 3 squared, right? Which is x plus 3, okay? So that is the LCD, x plus 3, x plus 3. So now exactly, since this is LCD, so I'm going to multiply the first fraction by x plus 3 because we have one x plus 3, another one is missing. So I'm going to complete that. So the other one, we don't touch it. The other one is x plus 3, we don't touch it, right? So it's going to be x plus 3. And here at the top here, this one we have 2 parentheses x plus 3 and then plus 4, all right?
Oh, that I distributed the 2, but since it's already.
Yeah, we distribute, exactly. That's going to be our next step. We distribute the 2. It's going to be 2x plus 6 plus 4 over x plus 3, right?
But can't we just cross out one of each of the x plus 3s in the.
No. Then, you know, then 2 things. We cannot single out the x plus 3 here and do the crossing like that. We cannot do that. That is one reason. The other reason, even if that was possible, you would come back to the, you know, that is not, mathematically, we cannot isolate somebody just from an addition. From an addition or subtraction, you cannot just isolate one term. Let's cross them out, right? So you have to do this. You have to do 2x plus 10 over x plus 3. That's it. And here, we can stop right here, okay?
Okay.
Stop right here. All right, thank you very much, Noah. So I'm going to give you another one, probably, or 2 of them, right? The first one is this one right here. Okay, and then the other one, I'm going to get it from the book, and then I think it's going to be enough for this topic. In each of these right here, you have to factor. After you have factored, you have to find the LCD. Only after you have factored, right? All right, go ahead. All right, so let's see. What do you think about the first one? Somebody go ahead.
I can do it.
Uh-huh.
The 7x, the x2 minus 2x minus 15. It's
Uh-huh.
like, put that into the groups, which would be x plus 3
Uh-huh.
times x minus 5.
Thank you very much. That's correct. So what is LCD then?
X plus 3 times x minus 5.
Exactly. So the LCD is the big one because the big one includes the small one, x plus 3, x minus 5. Thank you. So now, do you change anything in the first fraction then?
No.
What you did to the second fraction?
You multiply the top and the bottom by x plus 3.
Thank you. That is correct, right? Everybody see that? So now you have a single fraction here. What do you have, what is your new denominator now?
It's x plus 3 times x minus 5.
Yep. And then the first, and then on the numerator, what you got?
Is 7x
Uh-huh.
minus 3 times x plus 3.
Yep. And then you did what?
And then I multiplied x 3 times x and negative 3 times positive 3.
Yes, it's a negative 3 minus 9, right?
Mhm.
And then negative 3x minus 9, and then you group the like,
It's
the like
4x.
terms.
Mhm.
It'll be 4x
Minus 9
over.
or x plus 3 times
Uh-huh.
x minus 5.
Thank you. Thank you very much. You see, that's how we add fractions, okay? We understand the next one could be a little bit, not a lot, but a little bit thing, because the LCD might be a little bit bigger, right? So again, somebody, so how we factor the first denominator? The first denominator, how you factor it?
I can do it if you want.
Go ahead, please.
So the first denominator would be factored, let's see if I'm in the right place, x plus 3 and x plus 2.
X plus 3 and x plus 2, that is absolutely correct, right? And the second denominator is factored as what?
X plus 2 and x plus 1.
X plus 2 and x plus 1. All right. And now I'm going to ask you, what is LCD from that then?
So you would need to include x plus 3, x plus 2, and x plus 1.
Thank you. Why you don't duplicate x plus 2? Why you don't write it twice?
Because it's already included.
Exactly. You see, we don't duplicate somebody unless they have different exponents, right? But if it's the same one, you don't duplicate it, you just write it once. So the LCD here is the first expression that includes everybody else, right? Everybody, each factor would be in the LCD one time, right? Each factor will be in the LCD. You see, x plus 3 is in the LCD. X plus 2 is in the LCD. X plus 1 is in the LCD, right? Thank you. So now, okay, now you look at the first fraction. What you have to do to it to get the LCD at the bottom? What you have to do with the first fraction?
You want me to keep going?
Yeah, keep going on it, please.
Okay. So you have to multiply the numerator by x plus 1. So
Yes.
x times x plus 1.
And yes, everybody see that? The LCD here, I look at the LCD, x plus 3 is here, x plus 2 is here. So the missing piece is x plus 1, and I put the missing piece, right? Okay, I now go to the second one. Okay, what is the missing piece in the second one?
X plus 3.
The x plus 3 is missing. I put x plus 3, right? You see? Now I got a big fraction like that. What is the denominator now?
X plus 1, x plus 3, x plus 2.
Yes. And then what's going to be my numerator now?
X times X plus 1
X times X plus 1, which is the first one, minus.
minus 2 times X plus 3.
Thank you very much. You see, our goal is to reach here. When we reach here now, that is the goal of today. After that, it's just simplifying, right? But the goal of today is everybody to be able to reach here. That is the goal of today, okay? So now we have just to, you know, distribute x squared plus x minus 2x minus 6, right? Which is x squared minus x minus 6 over x plus 1, x plus 3, x minus x plus 2. You know, in the very extraordinary circumstance, maybe this one could be simplified. We don't know, right? But why not try? You see, but this doesn't happen every time, okay? So my goal here, again, what we're learning today is not about simplifying, it's about to get here, right? But this numerator is so nice, right? So why not try to factor it? Maybe something will be simplifiable, right? So how we factor the numerator here? X minus 3 and x plus 2, right? You see, over x plus 1, x plus 3, x plus 2. And again, this doesn't happen every time. This is x plus 2 cancel out. And we get x minus 3 over x plus 1, x plus 3, okay? So, all right, so everybody, you know, you can write your name for the attendance, please. So this is, you know, I think we practice enough. I think now you have to continue with, you know, with practice, my open math, the textbook, all that, you know, if you have plenty of time, you know, I invite you to do, you know, a lot of problems, you see, because it does help. It does help to do a lot of problems. It really does. So now, after that, of course, the next section is a section 2.5. You see, addition is a little bit harder than multiplication, as you can see. Multiplication, you don't need this LCD, right? You don't need none of that for the multiplication. But addition and subtraction, you need the LCD, okay? We do need the LCD, that's the difference. So the 2.5 is proportions. Even in our daily life, it's very important to understand how proportions work, right? Even in our daily life, okay? So let's say, for instance, you have your son or your daughter, right? And you want to give them medication, right? And they say, okay, if the weight is 18 pounds, you have to give them one teaspoon, right? If the weight is 18 pounds, give them 1 teaspoon, okay? But your kid is not 18 pounds. They are 25 pounds, you see? And you wonder, okay, how much should I give them? I don't want to give them only 1 teaspoon. It might not be effective, but at the same time, I don't want to give them, like, 2 of them, because it might be more, right? So every now and then we find ourselves doing those type of calculations, okay? This is about proportions. This section is very important right here. In practice, in practice, we have to know about proportions. We have to know that. So it starts with this. if A over B is equal to C over D, right? If two proportions are equal, then what should be also equal? Then AD must be equal to BC. Then AD must be equal to BC. What is the proof of that? Why? It's very simple, actually, it's a proof of that. Look, if you have A over B is equal to C over D, right? Okay, what is the LCD here? What is LCD? I have two denominators, B and D, right? What is LCD?
BD.
BD, right? Let me go and multiply by BD here and BD here, which I have the right to do, right? Every time you multiply a fraction by the same thing, you have right to do that. An equation by the same thing. Look the B. Here, what happens to the B's? They cancel out, right? I have AD left. And here, the D's cancel out. I have BC left, right? This is where this stuff come from, okay? So if you say 6 over 8 is equal to 3 over 4, right? If I want to check if that is true or not, if I want to check if that is true or not, I have to cross multiply, right? We call that cross multiplying. If the cross multiplication is equal, then that is true, okay? If the cross multiplication is not equal, then that is not true, okay? So the cross multiplication, what is 6 times 4? It's 24, right? And what is 8 times 3? Also 24, so that is true, okay? So that is every time you have a single fraction equal to another single fraction, then you can go ahead and cross multiply, right? I'm not saying two fractions, I'm not saying something that involves 3 fractions. I'm not saying only one fraction equal to another one only, right? Only one fraction equal to another one. So if you have this, solve for x. If I have this proportion right here, 20 over 6 is equal to x over 9. Okay. You see, I have one fraction equal to another fraction. What can I do? What the formula tells me? The formula tells me what?
6 over 9, it would be, oh, I think I did it wrong. Oh no, 20 times 9 is 180.
The formula tells me 20 times 9 must be equal to what?
180, and then 6x
Exactly.
must be equal to 180.
That is a cross, that's what you call cross multiplying, right? Every time you have a single fraction equal to another single fraction. Ever see that? Visually, that is very, very easy to remember visually, right? So that means 20 times 9 is equal to 6 times x, which is 180 equal to 6x. Now what you do to get x by itself?
Divide by 6.
Divide by 6, divide by 6, so we get x equal to
30.
180 over 6 is 30, right? Okay, so that is what you call proportions. So now we can go ahead and, so this is almost time, but just the next one, next proportion, and we're gonna stop right here for today. So, all right, solve for X, same thing. Solve for X, go ahead.
Is it going? Oh.
All right, solve for X. I think it's almost time, right?
Yeah.
So how we cross multiply? So we have to cross multiply, right? We have to do this and this. Okay, here to avoid mistakes. What is something which we cannot, you know, if I do 5x plus 3, what is missing? What is missing? Can you tell me what is missing?
Sorry, I didn't realize my thing was on that. Hold on. Well, you have to distribute that 5, don't you?
Yeah, so what is missing in my writing here? At
It would
first.
be 5x plus 15, not 3.
Yes, okay, so that is the next step, but this is the first step here.
Parentheses.
Parentheses missing, exactly, you see? So, and then I always advise you, I would advise you to do, so don't rush to the last step. No, write exactly what it should be, and then you see that. This way you're gonna avoid mistakes, okay? And then of course we have to distribute the 5. It's gonna be 5x plus 15 is equal to 8. What next we have to do? Minus 15 minus 15. So we get 5x is equal to negative 7, and then we divide by 5.
Minus.
Right? Okay, so x is equal to negative 7 over 5. So when we come back next week, we're going to practice more of this section. But, you know, as you see, the proportion section is, you know, okay, I will probably next week, I will put the review sheet on Blackboard, like as promised, right? For the test number 1, which is October the 5th, I think. I will put the review sheet on Blackboard. But remember, the review sheet is going to be only about few problems. If you want to master a topic, you have to practice a lot, right? Okay? It's not like, you know, practicing like 2 problems in a topic. If you have time and you can solve like 10 problems in the same topic, go ahead and do that, all right? All right, everybody. Thank you very much, everybody. And have a blessed week. All right, see you next week. Thank you.
Thank you.
Thank you.
Bye.
Thank you.
Thank you. See you next week.
Bye.
Thank you.